Welcome back to Introduction to Software Reverse Engineering. In this module, we will explore structures and the ways that structures can be passed into functions as parameters in C. Get ready for a lot of practical work today. Welcome to Module 12. In this module, we will continue talking about structures. We will look at the example of a structure with nested structures inside it. And we will look at and examine the ways how structures can be passed as parameters into functions. Let's start. In this module, I want to review another simple example program that showcases passing structures as function parameters, both by reference and by value. I want to review the code generated by the compiler and learn from the experience in order to be able to detect passing a structure by value for the future reverse engineering undertakings. All the materials covered in this course are available on GitHub. The link is on the screen right now and in the description below the video. In C, structures can be passed to functions in two ways, by value and by reference. Passing by value creates a copy of the structure, which is then passed to the function. Modifications made within the function do not affect the original structure. This approach can be inefficient for large structures due to the overhead of copying. Passing by reference involves passing a pointer to the structure. Changes made within the function affects the original structure. This method is more efficient for large structures as it eliminates the need for copying. The choice between passing by value and reference depends on the specific requirements. Use pass by value for small structures that should remain unchanged, and pass by reference for large structures or when modifications to the original structures are necessary. Fire up Ghidra and import new example program, nestedstructs.exe, and make sure it goes through automatic analysis. In this module, we will work with this simple application that fits into one single screen. The program has a structure with nested structures as its members. The program also has two functions, one that prints values from this large combined structure and the other one that populates it. Let's take a look at the latter function. It's the compiled version. The function that populates two members of the large structure is on the screen. As you might have expected, its members are treated right now as independent structures that are populated on lines 14 and 16 independently. These structures have been passed into the respective functions to be populated by a reference or a pointer. Moreover, the print function, see line 24, is missing parameters. Let's review its source code. The function that prints out this large structure accepts it by value, meaning that a copy of the structure passed into a function as a parameter. In practice, this means that all the structure bytes are passed into the function in a way that conforms with the function's calling convention, either through the stack, registers, or a combination of both. Let's take a look at the printing function. It lacks the necessary parameters for the printf function. Go ahead and fix that. With the printf signature corrected, Ghidra pulled in missing parameters. There are a lot of parameters. Notice that all the parameters for the printf function have instack prefix in their name. This is an indication that these values are coming into the function through the stack as 1. Either a number of individual parameters, or 2. As a structure being passed by value. To distinguish these cases, additional information is needed. Let's go back to the previous function for this piece of information. But before doing so, let's review the source code again. See that the large structure is being passed into the function by value. Now, let's go to Ghidra. The decompiled function has a block of code missing in the original source code. This block, lines 18 through 23, makes a copy of the data before passing it to the printing function. However, given that Ghidra did not identify the function parameters correctly, the code seems to be out of place and meaningless. Now, let's create the structure to handle this parameter passing by value. Right-click on nestedstructs.exe in the Data Type Manager window and select New Structure, Context Menu item. The Structure Editor window will appear on the screen. Fill its members with two system time structures as shown on the screen. Don't forget to save the changes before closing the window. Once the structure is defined, you should be able to find it in the Data Type Manager window. Now, let's instruct Ghidra that the printing function accepts this large structure as the parameter by value. Right-click on the function's name and select Edit Function Signature Context Menu element. In the Edit Function window, add new parameter with the newly created structure as its data type. Note that the storage of it, a whopping 32 bytes of data passed through the stack. Click OK to apply the change. After the change was applied, Ghidra showed a lot of previously hidden operations in the decompile window. That's a lot. I encourage you to review all of them at your own. Now, let's see how the printing function changed after its signature was changed so drastically. The function did change indeed. It is pulling all the relevant data needed for printing local and UTC times from the members of this large structure. In this module, we reviewed passing structure as functions parameter by reference, which we have seen multiple times throughout this course already. Additionally, we look at the mechanics of passing the structure by value. This is pretty rare use of structures and usually done only for small structures and in a very limited set of use cases, given all the overhead needed to facilitate such operation. In the next module, we will look into unions and reverse engineer an application that uses unions. And, as usual, all the source code and the binaries for this course are available on GitHub at the link shown on the screen and at the link available in the description to this video. If you are looking to dive deeper into software reverse engineering, I'd like to recommend my book, Software Reverse Engineering: Navigating x86 Windows Applications with Ghidra. This course draws heavily from the book's content. However, the book itself contains many more examples and insights that can help developing your reverse engineering skills. The book is available in both print and digital Kindle versions on Amazon, making it easy to access and read wherever you are. Additionally, the book covers subjects not discussed in this course, such as reverse engineering of C++ programs, classes, virtual functions, and more. I encourage you to check it out. Thank you so much for watching and learning with me today. If you found this video helpful, please hit that like button and subscribe for more content like this. Your support means a lot to me. If you have any questions or topic you'd like to discuss, leave a comment below or shoot me an email. I'm happy to chat. If you'd like to support me and the channel financially, you can do so through Ko-fi or Patreon. Links are in the description below. Thanks again for watching, and I will see you in the next video.